Hi dear students, I am Dr. Mashu. Welcome to my class. Today I would like to discuss different methods used for the purification of water, and in that we can see chlorination, filtration, distillation and UV light mediated purification of water. First we can see the method of filtration. In the filtration method, the solid particles will be removed from the suspension in a liquid by means of a porous medium or a screenhouse or by a screenhouse. In this filtration method, solid particle will be retained in the filtration medium, and the filter medium will allow this liquids to pass through it. And the principle behind this filtration process is this filter medium only allow the liquid to pass through it, and that liquid will be collected as a filtrate, and the solid will be present on the this filter medium, and the volume of filtrate is produced per unit time, that is known as a rate of filtration. Okay, that means this filter medium only allow this liquids to pass through it, and this liquids is collected as a filtrate, and the filtrate is collected, the volume of filtrate is collected per unit time, that is known as a rate of filtration. And during this filtration, this solid particle will be accumulated over this filter medium, and that will form a filter cake. And during the process of filtration, the more and more amount of solids will be accumulated in this filter medium, and that will make a resistance to flow of this liquid or the filtrate to flow through it, the filter medium. Okay, that means during the process of this filtration, large amount of solids will be attached on, that will form a filter cake, and large amount of this solid particle will be attached on the filter medium, that will make resistance to flow of this liquid. Okay, and in the filtration medium, the filtration medium used in the filtration technique, there may be surface filters or depth filters. In the case of surface filters, that work by direct interception of particles larger than the pore size of this surface filters. That means the particles larger than the pore size that will be intercepted by this this filter, and this dirt or this solid particle will be accumulated over the downstream upstream portion of this filter, and at the time of starting of this filtration process, the flow of liquid will be high, and as this filtration process will be progress, and a large number of solids will be accumulated of this surface filter. That's why the flow of there will be some resistance to the flow of liquid. This is about the surface filters. That means in the case of surface filters, the surface filters, these particles will be particles larger than the pore size will be intercepted in the surface filter, and the dirt or this solid particle will be accumulated down upstream of this filter, and at the time of this filtration at the time of beginning of this filtration process, the flow will be high in the through this filter, and as the process is process of this filtration will progress, that time that will accumulate large number of solids on this filter, and that's why that solids will create resistance to flow of this liquid. Okay, this is the surface filters, and in this figure you can see the surface filtration method, surface filters, in that this suspension is coming from the top of this filter, and the solid is present, the solid is accumulated upstream portion of this filter. This is about the surface filtration. Now we can see the depth filters. This depth filtration method that will use a porous filtration medium for this filter process, and the solid particles or dirt particles that is have to be removed from this suspension, that will be accumulated throughout this filter medium. Okay, in the case of this depth filters, the solid is accumulated throughout this filter medium. But in the case of surface filters, that means screeners or meshes filters, this solid particle will be accumulated on the upstream portion of the filter. But in the case of depth filters, this solid particle accumulate all over the filter medium. And this depth filters is used in the water purification system when there is a high load of dirt or solid be present in the water purification system, and this depth filter can accumulate large mass of particles inside the filter medium before it become clogged. Okay, that this filter medium can able to accumulate large amount of solids before it become clogged. And this filter are commonly characterized by the sand filters and having high filtration rates compared to other filters. Okay, this depth filters are commonly characterized by the sand filters and have high filtration rates than other designs or other filtration process. Okay, this is the depth filters. Okay, depth filters are the filter element that use porous filtration medium for the filtration process, and this during this depth filtration process, the solid particle will be accumulated throughout this filter medium. And this depth filtration process is used when this water contain a high amount of high load of solid or dirt particles in this water, and this depth filters is used for the removal of high amount of water present, high amount of dirt is present in the water, and the filter can able to retain or accumulate large amount of solids inside the filter medium before it become clogged. Okay, and these depth filters are commonly characterized by the sand filters and having a higher filter rate than any other filtration process. Okay, this is about the depth filters. And in this figure you can see the depth filters, and it having the suspension is coming from the upstream position, and this solid park is accumulated all over this throughout this medium, you can see. And sometimes this filtration method will be not work efficiently. That time modern technologies offer some membrane based filtration methods like ultrafiltration, and ultrafiltration method is the, and other one is the nano filtration method is the, and reverse osmosis method also is the one of the modern technique of filtration. First we can see the ultrafiltration. An ultrafiltration filter has a pore size of around 0.01 micron size, and this ultrafiltration would remove the large particles, and it may remove some viruses also. Okay, this ultrafiltration, this filter having pore size of around 0.01 micron size, and the ultrafiltration will remove these larger particles, and it may sometime remove some viruses. Okay, it can't able to remove all viruses, but it can remove some viruses because it depends on the size of the virus. You can able to remove some viruses. And Neither microfiltration or nor ultrafiltration can remove dissolved substances. Okay, this microfiltration or ultrafiltration cannot able to remove the dissolved substances present in the water unless they are absorbed with activated carbon or coagulated with alums or iron salts. That means this microfiltration or ultrafiltration cannot able to remove the dissolved solids present in the water. Okay, this is about the ultrafiltration. Okay, ultrafiltration having the filter having a pore size of around 0.01 micron size, and ultrafiltration would remove these large particles, and it can able sometime it can able to remove some viruses, and neither microfiltration or this ultrafiltration cannot remove dissolved substances present in the water. Okay, this is about the ultrafiltration. Another filtration method is called the nanofiltration. A nanofiltration filter has a pore size of around 0.001 micron size, and this nanofiltration method can remove most of the organic molecules, and nearly it can able to remove all viruses and most of the natural organic matter and range of salts. Okay, and nanofiltration can also remove divalent ions and which make water hard, and so nanofiltration is often used to soften the hard water. Okay, this is about the nanofiltration. And the nanofiltration, the nanofilter has a pore size of around 0.001 micron size, and this nanofiltration remove most of the organic molecules, and it can able to remove the most of the organic natural organic matter, and it can also able to remove range of salts, and this nanofiltration can able to remove nearly all viruses. Okay, but in the case of ultrafiltration it cannot able to it can only able to remove some viruses. That's because of the pore size of this filters. In the case of ultrafiltration, there is a filter size is a 0.01 micron, and in the case of this nanofiltration, the pore size is the 0.001 micron. Okay, that's the difference, and that means the porosity of this ultrafiltration is high, and the porosity of nanofiltration is less. That's why this nanofiltration is can able to remove large number of viruses compared to this ultrafiltration, and ultrafiltration can only able to remove some viruses, but this nanofiltration can able to remove nearly all viruses. Okay, and next filtration is a reverse osmosis, and this reverse osmosis filter have a pore size of around 0.001 micron size. Okay, reverse osmosis filter having the size of 0.0001 micron size. Okay, and after passes through the reverse osmosis filter, it is essentially pure water. Okay, and reverse osmosis remove all organic molecules, viruses, most minerals, and monovalent ions, and all particles will be removed by the reverse osmosis process. Okay, this is about the reverse osmosis process. In the case of reverse osmosis, this reverse osmosis filter having the pore size of 0.0001 micron size. Okay, but in the case of ultrafiltration, the filter size, the porosity of the ultrafilter is the 0.01, and in the case of nanofiltration, the filter size, pore size is the 0.001 micron. But in the case of reverse osmosis, the filter size, pore size is the 0.0001 micron size, and this reverse osmosis can the water that is passed through this reverse osmosis filter, that is essentially pure water, and this reverse osmosis filter can able to remove all organic molecules, viruses and most minerals, and it can also able to remove monovalent ions, etc. This is about the filtration method that is used for the water purification. Okay, these are the filtration method. Okay, there we told that in this filtration method there are two type of in the filter medium two type of filters were used. One is the depth surface filters and depth filters, and after that we discussed the modern technologies that came in the filtration method. There is a ultra filtration, nano filtration and reverse osmosis method of filtration. This is about the filtration. Next, we can see the chlorination method of water purification. And the chlorination is one of the many methods that can be used to disinfect the water. And this method was first used over a century ago, and this method is still used today. Okay, the chlorination is the one of the many method that can be used to disinfect the water, and this method was first used a century ago, and this method we are also using still we are using this method for the this purification of water. And it is a chemical disinfection method that use various types of chlorine or chlorine containing substances for the disinfection. Okay, this chlorination process is the chemical disinfection process, and that use various type of chlorine or chlorine substances for the disinfection. And the advantage of chlorination is that it has proven effective against bacteria and virus. This chlorination method is found to be effective against many bacteria and viruses. And the chlorination process is also fairly easy to implement when compared to other water treatment method. Okay, this chlorination process is easy to implement. This chlorination process is easy to implement compared to other waste this water purification method. And this chlorination method is effective method in the time of water emergency. Okay, this chlorination method is highly effective method in water emergency. And mainly three most common type of chlorine used in the treatment of waste this purification of water, that are one is chlorine gas we can use, and we can use sodium hypochlorite, and we can use calcium hypochlorite. Okay, this is a three type of chlorine that are used for the treatment of water. One is chlorine gas we can use, sodium hypochlorite we can use, and calcium hypochlorite we can use. And the chlorine is one of the many methods that can be used for the treatment of water. And is this chlorination method used a century ago, but still we are using this chlorination method. And this is a chemical disinfection method, used various type of chlorine and chlorine substances in the chlorination process. And the advantage of chlorination process is it has proven effective against all bacteria and viruses. Okay, this chlorination method is highly effective against bacteria and viruses, and this chlorination process is effective, highly easy to implement compared to other water purification mechanisms. And is this chlorination process highly effective in the case of water emergency. And there are main and there are three most common type of chlorine were used for treatment of water. One is chlorine gas, and one is sodium hypochlorite, and third one is a calcium hypochlorite. The principle of chlorination mechanism is The chlorine inactivates the microorganism by damaging its cell membrane. Okay, this chlorine will inactivate a microorganism by damaging its cell membrane. And once the cell membrane is weakened, the chlorine can enter the cell and disturb the cell respiration and DNA activity. Okay, that means the chlorine inactivate the microorganism by damaging its cell membrane, and once the cell membrane is weakened, the chlorine can enter to the cell and disturb the cell respiration and DNA activity. And these two process, cell, cell respiration and DNA activity, these two processes are necessary for the cell survival. Okay, that means this chlorine will be and awaken the cell membrane, and that will enter the cell, and that will disrupt the cell respiration mechanism, and it also affect the DNA activity. That's why this microorganism will be inactivated. This is the principle of chlorination method. Okay, this chlorine will be inactivate the microorganisms by damaging cell membrane, and after the weakening the cell membrane, this chlorine will be enter into the microorganism, that will disrupt the cell respiration, and that will inactivate, or it will affect the DNA activity. Okay, that's why this microorganism will be inactivated. This is about the chlorination method of water purification. And the next method used for the water purification, that the distillation method. Okay, now we can see the distillation method of water purification. Distillation is the process of that rely the evaporation to purify the water. Okay, and the contaminated water is heated to form a steam, and this distillation can able to remove nearly all impurities from the water, and the distilled water will be 99.5% pure. And distillation will remove sodium, hardness compounds such as calcium, magnesium, other dissolved substances including iron, manganese, fluoride, and nitrate. And this distillation process will inactivate the microorganisms such as bacteria, virus, protozoa, and protozoan cyst will be inactivated by the process of distillation. And distillation also can remove many organic compounds, heavy metals such as lead, and it can able to remove chlorine and chloramines. And distillation also able to remove some remove some oxygen along with the trace elements, which give water a pleasing taste. Okay, and people often claim this distilled water tastes as a flat or bland. Okay, this is the okay, the distillation is the process that relays the evaporation to purify the water, and the contaminated water will be heated to form the steam, and a distillation can able to remove all impurities present in the water, and the distilled water will be 99.5% pure. And distillation can able to remove sodium, and it also can able to remove hardness compounds such as calcium, magnesium, and it's also can also able to remove dissolved solids such as including ions, manganese, and it's also can able to remove this fluorides and nitrates. And if this filtration mechanism calls an able to inactivate the microorganism like bacteria, virus, protozoa, and protozoan cyst. And distillation can also remove many organics compounds like heavy metals like lead, chlorine, chloramines, etc. And sometimes this distillation also remove oxygen along with the trace elements. That's why these people sometimes claim this distilled water as a flat or bland. And the principle and procedure of distillation is the distillers use heat to boil the contaminated water and to produce steam. Okay, the instrument used for the distillation, that is known as distillers or distillation unit, and distillation unit use heat to boil the contaminated water and that will produce steam. Okay, impurities such as inorganic compounds, large non-volatile organic compounds are not vaporized and left behind in the boiling chamber of the unit. Okay, that means the water present in the contaminated water will be evaporated, and other compounds such as inorganic compounds, large non-volatile organic compounds are not vaporized and that will be left in the boiling tank of the boiling chamber of the distillation unit, and the steam rises and enters into a coiling section. Okay, the steam will be rises from the boiling chamber and the steam will be enters into the cooling section, and that containing this cooling section contain a condensing unit, and from there this steam will be condensed into the pure water. Okay, means this water will be evaporated from the heating chamber, from that steam will be arised and that will be steam will be entered in the cooling section containing the condensing coils, and from the steam will be condensed into back to liquid, and water will be flows into the container for the collection of purified water, and the water remaining in the boiling chamber. Okay, the water remaining in the heating chamber or the boiling chamber will contain high concentration of impurities, and this water will be drained by drain and discard. Okay, here we can see this is a principle and procedure. Okay, the distillers and or the distillation units use heat to steam produce the steam from the contaminated water, and this impurities such as organic compounds, inorganic compounds, and large volatile non-volatile compounds will be retained in the distillation unit or this boiling chamber, or that will be and then does not become vaporized, and this water will be vaporized, and this steam will be entered into the cooling section of this distillation unit, where is the condensing coil will be condense the steam into the steam back into the water, and this water will be collected in another container as a pure water, and the remaining water present in the container that will contain a high amount of impurities, and this impurities containing water from will be drained off from the boiling chamber. This is about the distillation mechanism and distillation, the principle of this distillation unit, and the heat produced, the heat that is given into the distillation unit, that the heat will remove or kill the bacteria microorganism present in the water. Okay, this is the principle and procedure of the distillation process. And this figure explain what is the distillation process and the distillation unit. Here you can see one heating chamber is the where you can see the heat is given from the down of this distillation unit, and this heat will cause the evaporation or produce vapor from this contaminated water, and that vapor will be and it is a cooling part of this distillation unit. From that cooling part, this condensing coil will be condense the vapor into the water, and that's water will be collected as a pure water in a container, and you can see the boiling chamber that is contain a high amount of impurities. This is about the distillation process of water purification. Now we can see the UV method of water purification, and the ultraviolet rays are the part of light comes from the sun, and the UV spectrum is higher in frequency than the the visible light, and lower in frequency compared to X-rays. And in the water treatment, this UV method is considered as an effective disinfectant due to the its strong germicidal activity. And this UV or disinfectant can able to remove bacteria, virus, and protozoa, and like organisms. And this ultraviolet light prevent the bacteria from the water, and it can able to prevent the spreading of bacterial disease through the drinking water. And it does not remove particles from the water. Okay, this UV light does not remove the particles from the water. It's only having the germicidal activity. And UV has been commercially used for many years in a pharmaceutical, cosmetics, beverages, and electronic industries, especially in foreign countries. Okay, this ultraviolet rays are come with the part of lights come from the sun, and UV spectra having higher in frequency than the visible light and lower in the frequency than the X-rays. And as a water disinfectant, this UV is considered as an effective disinfectant because it is a strong germicidal activity. And this disinfectant UV can able to kill can able to inactivate bacteria, virus, and protozoa. And this ultraviolet can able to prevent the spreading of disease through the drinking water by that caused by the bacteria. Okay, and it has been commercially, this UV is commercially used for many years in the pharmaceutical, cosmetics, and beverage electronic industries, especially in the foreign countries. Now we can see the principle behind this UV disinfection. And UV radiation having three wavelength zone. One is UVA, UVB, and UVC. And it is the last region, the short wave UVC has the lethal activity, and that has the germicidal property for the disinfection. And for the industrial or commercial purpose of UV disinfections, we use low pressure mercury arc lamp resembling a fluorescent lamp produce UV light in the range of 240 to 254 nanometer wavelength. Okay, this low pressure mercury arc lamp will be used in the for the UV treatment process in the UV purification instruments. And UV radiation affect microorganisms. Okay, we told that UV having the germicidal activity. Now we can see how this UV is affect the microorganism. Okay, this UV radiation affect the microorganism by altering the DNA in the cell by producing thymine dimers and impeding the reproduction. Okay, this UV radiation will cause the alteration in the DNA of the bacteria or other organism, and that will producing thymine dimers. Okay, this thymine dimers will cause the make problem for the DNA due the time of DNA replication and DNA transcription. And by this thymine dimers, it will be embed is inactivate the reproduction of bacteria. And UV treatment does not remove organism from the water, and it is merely inactivate them. Okay, This UV does not remove the microorganism present in the water. It just inactivates the bacteria or organism present in them. And presently, most of the commercial water purification system contain UV light for the purification purpose. Okay, this is about the water principle of UV disinfection. That means UV radiation has in three wavelength. One is UVA, UVB, UVC, and the last part, last region, UVC, having the lethal activity. That's used as a germicidal activity in the UV disinfection process. And for the purpose of UV disinfection, low pressure mercury arc lamp is used for the UV disinfection, and that will produce the UV light in the range of 254 nanometer range. And this UV radiation affect the microorganism, altering the DNA, and in the that's why it will inactivate the reproduction. Okay, this UV light will produce thymine dimers in the DNA of microorganism, that will lead to inactivation of the microorganism. And this UV treatment does not remove the microorganism present in the water. It just inactivates the microorganism, bacteria or microorganism present in the water. And presently, most of the commercial water purifier that contain UV light for the purification of water. And this figure you can see the this UV ultraviolet based water purification system. Here you can see the water is coming from the down part and is coming into the UV UV light UV tube containing chamber, and this you can see the treated water will be comes out. This is about the ultraviolet mediated water purification system. Okay. Okay, these are the methods used for the water purification system, and some other method also is there, but this is a major type of water purification system. We can also use sedimentation, and in the previous one video I have done the sedimentation process for the that is used for the water purification system. You can also take that sedimentation. You can also see the sedimentation video for this to add with the water purification method. And I hope you understood this class. Thank you for the listening.